Hi everybody, this is Mr. Beckstrom, and today I want to take a look at one of the problems that was asked about in the forums. It said, assume that alpha is an angle in standard position whose terminal side contains the point -1, square root of 3. Find the exact values of the 6 trigonometric functions. So let's go ahead and solve this problem. And there's a couple of different ways to solve it once again, but I always like to do triangles here. So let's go ahead and put a makeshift graph here. And this is going to be -1, √3. So I'll put -1 here. And here's -1 there. So -1, square root of 3. If I take my calculator out and I kind of do an approximation of that, -2 square root of 3. That's going to be around -1.4 or -1.7, excuse me. So that'll be a little bit closer. Here's -2, so that's going to be down right about this point here. So -1, √3. So that is, oops, that is in our third quadrant. So we want to know, we're going to take that angle going to the origin. Make that a little bit better here. Going to the origin here. So there is our angle alpha here. And so we're going to look at the sine of alpha, the cosine of alpha, the tangent of alpha, the cosecant of alpha, the secant of alpha, and finally the cotangent of alpha. All right. So this is in the third quadrant. So in the third quadrant, my x's are negative, my y's are negative, and my x divided by y or my y divided by x is positive. So that means that sine and cosine are both going to be negative. So I'll go ahead and put the negatives out here. That means that cosecant and secant will also be negative. But since y divided by x is positive and x divided by y is positive, tangent and cotangent will be positive. So I can go ahead and put my signs in here already, so that way I don't even have to worry about those. Next, I'm going to go ahead and form my right triangle here along the closest x-axis here, which happens to be the negative x-axis. And with that right triangle, I have this side here is going to be length √3. This side here is going to be length 1, and that means my hypotenuse, I can just use the Pythagorean theorem to find the length of the hypotenuse. That's going to be 1 squared plus √3 squared is going to be equal to c squared. So 1 squared plus √3 squared is 4. So c squared is equal to 4. So c is going to be equal to the square root of 4, which is 2. So this side here is going to end up being 2. So I have my angle here, and now I can just use my SOHCAHTOA. So I'll go ahead and pull that down right here. So SOHCAHTOA, that a little bit bigger here. And so my sine of this angle here is going to be opposite over hypotenuse. So that will be, oh, I got to change that back to my pen here. So square root of 3 over 2. My cosine will be adjacent of this, remember, this acute angle right here, adjacent over hypotenuse. So that'll be 1/2. Tangent will be opposite over adjacent, so that's just going to be √3/1, which is just √3. The cosecant will be 1/sine, so that's just going to be 2/√3, just the reciprocal of that. 2/√3, and if we want to rationalize that denominator, we can write that as -2√3/3. Either one of those is fine. If it doesn't, my math lab doesn't take this, it'll take that. Secant is just going to be 1/cosine, so that'll just be -2/1, which is -2. And cotangent is just the reciprocal of the tangent, so that'll be 1/√3. And that can also be written as √3/3 if we multiply the top and the bottom by √3. All right. If you have any questions with that one, let me know. And I hope you have a great rest of your weekend. Thanks a lot.